As stated in the previous video, these next four examples are examples of equations that create special cases for their solutions. And what happens is that the variables end up canceling out. And you'll see what I mean when we start solving E, first of all. In E, the first thing we're going to do is distribute the 2 to get rid of those parentheses. So we're going to distribute that 2. So the equation we have after we do that is 10x plus 12 is equal to, when we distribute that 2, we end up with 10x plus 12. And then once again, that is the distributive property. Okay. So, sorry the pen is a little slow. I must be trying to do too much with my computer right now. Now, the next step, as discussed in the previous video, is we want to get the variable on one side of the equal sign. So we're going to do that by moving this 10x by subtracting it. From both sides. And that is the subtraction property of equality. I'm looking for a reason. Now what happens here is that 10x minus 10x, they cancel out. The 10x minus 10x cancels out on the right side as well. That's why we subtracted it. So what happens is that the variable completely cancels out. So the equation we are left with is 12 equals 12. And that is the equation we are left with. Now, when this variable completely cancels out, you are either going to be left with something that is always true or something that is never true. Some constant is equal to some constant. Now, in this case, 12 equals 12 is always true. Okay? So what that means is that this equation is always true no matter what x is. X could be 1, x could be 7, x could be 1,255,736.768,910. Something like that. So, since that equation is always true no matter what value of x you have, x is, or x can be, any real number. So that is one case where you have a special case for the solution for this equation, where the variable completely cancels out and you are left with something that is always true, which means the original equation is always true no matter what. So in this case, x is any real number. And I'm not really writing that slow, the pen is just acting slow. All right, so in the next one, the first thing we need to do is combine like terms. We need to combine the negative 3m and the 12m on the right side. Now, notice the difference between this one and the previous examples we've done. We are not yet moving a variable term to the other side. Both the 3m and the 12m are on the same side of the equal sign. So you combine them just the way they are. You take negative 3m plus 12m. A common mistake that students like to make is that they want to add 3m. Okay? But you only change that sign, you only do the opposite when you're moving something across the equal sign, which we are not doing here. So once we do that, we have 9m minus 4 is equal to, when we combine those two, negative 3m plus 12m is also 9m plus 5. Now we want to get the m's on the same side by subtracting 9m from both sides. And again, that is the subtraction property of equality. So the m's cancel here, the m's also cancel here. So we are left with negative 4 is equal to 5. And once again, just like back here in this example, we end up with a constant is equal to a constant. But in this case, when is negative 4 equal to 5? Well, never. So we've arrived at an equation which is never true, which means the original equation is never true. Doesn't matter what x is. X could be anything in the world, that equation will never be true. So therefore, we have no solution. And those are the two basic special cases that we have for these two when that variable completely cancels out. And again, that can happen when you have a variable on both sides of the equal sign. So G and H can be similar to these. So we're going to solve H. The first thing we're going to do, G, the first thing we're going to do is use the distributive property to get rid of those parentheses. When we distribute that 3, we have 12b minus 2 is equal to negative 6 plus 12b. And several of you have caught that already, I hope. I forgot, and that's how common a mistake can be. I forgot to multiply the 3 times negative 2 to get negative 6, and that is a very common error. So that is the distributive property. So next step, we're going to use the subtraction property of equality to get the b on the same side of the equal sign. And that is the subtraction property of equality. And once we do that, b's cancel on the left side, b's cancel on the right side, so we're left with a constant is equal to a constant. So then you ask yourself, is that always true or never true? Since that is always true, this equation up here is always true. So therefore, x is any real number. X can be anything. And last, solving H. Once again, we have the distributive property. We're going to distribute that negative sign, which what that does is it just changes the sign of everything inside. Once again, that is the distributive property. Now we want to use the subtraction property of equality to get the x on the same side. Once again, that's the subtraction property of equality. And once we do that, x is canceled there, and the x is canceled there, so we have 7 equals negative 3. This is a special case. 7 is never equal to negative 3, so therefore this equation is never true. So therefore we have no solution. So once we have a variable on both sides of the equal sign, we could end up with those special cases. May be kind of rare, but just so you know how to handle it when that arises, when the variable ends up canceling out. In the next video, we're going to look at a couple of word problems where we would have a variable on both sides.